This conference will now be recorded.
Right, let's start today's session. In the last session of Python, we were discuss about multi-threading programs, and there are so many methods we discuss, like isAlive method and active count method, and also join method and thread identification. And today we look into thread synchronization mechanism. What is thread synchronization? How do we work with that? Okay, so thread synchronization. Now coming to this, thread synchronization means thread synchronization. Thread synchronization means what? If multiple threads are executing simultaneously, if multiple threads are executing simultaneously, if multiple threads are executing simultaneously, then there may be a chance of if multiple threads are executing simultaneously, then there may be chance of data inconsistency problem. There may be chance of data inconsistency problems. In general, when we execute a program with multiple threads, if multiple threads are executing simultaneously or parallelly, then there may be a chance of data inconsistency problems. Okay, why data inconsistency problems? Let's look into an example, quick example I'll show you. Thread 8 program, it is thread 8. In this program, I'm going to show you the example if multiple threads are executing simultaneously, why data inconsistency problems are occurred, we'll discuss now. So that's what from threading import star, import time module I'm taking, and TF is the function name, function definition, F1 is a function name. This F1 function is expecting one parameter, that is name parameter, for I in range of 10 times I want to display. What you need to display, so just I'm displaying good morning. Okay, good morning. Then comma end attribute I'm taking. End attribute, why? Because I want to display in the same line only multiple times. Okay, then time dot sleep of 2 seconds time waiting period after, then I have to print the person name. So good morning, so and so person, like Sai, Mohan, like that. So T1 is a one thread is a class, target is what target function I'm taking, F1 function. But this F1 function is expect what? One parameter value, that is name value. So I'm trying to pass that arguments equals to what is the name, just Sai is the name. Okay, next I'm taking T2 thread also. T2 is a thread name, thread is a class, target equals to F1 function, args equals to like this Mohan I'm passing. This is one of the name again. So look at this, how many threads are executing in this program? Total 2 threads are there, T1 thread and T2 thread. But when we execute this T1 and T2 thread simultaneously or parallelly for F1 function always, so there may be chance of data inconsistency problems, means you will not get any regular output, you will get irregular output. Look at here. Is this regular output or irregular output? Obviously, it is a irregular output only. Okay, irregular outputs are, now you can see this. So here we are getting irregular output because both threads are executing simultaneously. We are getting irregular outputs because both the threads are executing simultaneously F1 function. To overcome this problem, we should go for synchronization. To overcome this problem, we should go for what actually? Synchronization mechanism. So in synchronization, the threads will be execute one by one. In synchronization, the threads will be execute one by one so that we can overcome data inconsistency problems. Threads will be execute one by one so that we can overcome data inconsistency problems, I'm saying. Synchronization means at a time only one thread will allow to execute. So, but in Python, synchronization we can achieve in three ways. Okay, we can implement synchronization in Python. We can implement synchronization 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 by using the following techniques. Synchronization by using following techniques, sir. Following techniques like this. We can implement synchronization by using the following techniques. Following techniques. What are the following techniques? One is lock mechanism, lock technique. Next one is R lock technique. Next one is okay, semaphore technique. Semaphore, I can say that. Lock technique, R lock technique, semaphore technique. These three techniques through we can achieve the thread synchronization mechanism. Thread synchronization means what? At a time only one thread are allowed to execute. So now I'm trying to discuss about synchronization by using lock technique, I'm saying. Synchronization by using lock, sir. Synchronization by using lock. Synchronization by using what technique? Lock technique. So locks are the most fundamental synchronization mechanism provided by threading module. Yes, this lock technique is the most fundamental synchronization mechanism provided by threading module, we can say that. Lock is the most fundamental synchronization mechanism provided by which module? Threading module. Okay, we can create lock object as follows. How to create lock object? L is a lock object equals lock is a class. L is a lock object and lock is a class. So L is a lock object. Now the lock object can be held by only one thread. The lock object can be held by only one thread, I can say that. The lock object can be held by only one thread at a time. Only one thread at a time. How many threads at a time lock object can be held? Only one. If any thread, if any thread, if any thread required, if any thread required the same lock, then it will wait, it will wait until thread release the lock. It will wait until thread release the lock only. Simple logics. If someone is using, someone is on the queue, okay, you are also on the queue, but there are so many persons on the queue. So one person can, over his turn, next turn will come to you only. That is one by one option like this. Here also, the lock object can be held by only one thread at a time. If any thread required the same lock accessing, then that will wait until the thread release the lock. Once first thread release the lock, then second thread will acquire the lock again. That is the concept, one by one. So that's what synchronization means, one by one thread. So we will get some clear output, regular output, we can say that, to avoid data inconsistency problems. Okay. And a thread can acquire the lock by using acquire method, ACQUIRE acquire method. A thread can release the lock by using release method, L dot release method. L dot acquire, L dot release. A thread can acquire the lock and a thread can release the lock by using acquire method and release method. Thread can acquire the lock by using acquire method. Thread can release the lock by using release method here. Okay. And most important thing is what I want to tell you. To call release method, to call release method, to call release method, compulsory, 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 compulsory. Thread should be owner of that lock. Thread should be owner of that lock. We can say the thread should be owner of that lock. That means thread should has the lock already. That means thread should has the lock. Thread should has the lock already. We can say that thread should has the lock already. Otherwise, otherwise we will get runtime error. We will get runtime error. We can say to call release method compulsory. Thread should be owner of that lock. That means thread should has the lock already. Otherwise, we will get runtime error. We can say that. Otherwise, we'll get runtime error. For example, look at this. So I'm trying to show you another example. Just let's go for previous example only. Just wait a minute. Yeah. Now you can see. I want to show you another example here. Thread should has the lock already. Then only thread can able to. Yes. Thread 8, thread 9. So what I mean to say here, to call the release method, compulsory thread should be owner of that lock. That means thread should has the lock already. Otherwise, we'll get runtime error. So that means what? Which thread is acquiring the lock? That thread only can release the lock. Suppose T1 thread is acquiring the lock, T2 thread is releasing the lock. Not possible. Okay, owner of the thread only should release the lock only. Okay, so same this. For example, you can see from threading import star, and now you can see this program is executed by which thread, sir? Main thread only. No? Every program executed by one thread, that is main thread. Internally in Python, every program is having one thread, that is main thread. Assume that this thread 9.py program executed by main thread only, and main thread acquiring the lock by creating its lock object, lock lock, L equals to lock object, sorry, L capital, lock lock object, and main thread only release the lock. Okay, L dot acquire, L dot release. So who is acquiring, who is releasing the lock? Tell me. Who is acquiring the lock? Who is releasing the lock? Okay, child thread acquiring the lock and child thread releasing the lock. Now let's run this. Now you can see we got this. There is no output. It is very clear. Because the main thread is acquiring the lock, main thread is only release the lock. For example, let me comment this line. When I do comment this line, what is happening? The child thread is not acquiring the lock. Okay, sorry, main thread is not acquiring the lock. But main thread is attempting to release the lock. But actually, owner of the thread only should release the lock, I said. But owner is not actually. No one acquired this lock again. So then owner is not acquiring the lock. Owner, how he can release the lock? This main thread, how he can release the lock? So you can see runtime error, release unlocked lock. Unlocked means unlocked. No one has lock. That is unlocked. You are releasing unlocked lock again. Already unlocked, that is. Again, you are attempting to release that lock. That is not. So owner thread only should release that lock. So if you want to release the method, then that thread should be owner thread only. Otherwise not. So this example I'm telling just for, okay, showing that. And now in this program, we can see thread synchronization, how we can achieve that. In this program exactly right now, which I am running, there is a irregular outputs are coming. Why? Because here T1 and T2 threads are parallelly or simultaneously running for F1 function. So we are not going to get proper output here. So this is data inconsistency problem. So if you want to make this program as data consistency, not inconsistency, then we can use lock technique. So lock is the very fundamental synchronization mechanism. The lock object can be hold only one thread at a time. If any thread required the same lock, then it has to wait until the thread release the lock. To call release method, compulsory thread should be owner of that lock. That means thread is having already lock. Otherwise, we'll get runtime error. So let's implement the lock technique for this program. How we can see this? Same program, two threads are there, T1, T2. These two threads are targeting F1 function only. I'm trying to acquiring the lock here. L equals to lock object I'm preparing. And whenever T1 start, immediately T1 thread is targeting which function? F1 function. When we call F1 function, then thread should be acquire the lock here, acquire method. After acquiring the first thread lock of this F1, total execution after completion of, then I have to release the lock because T1 thread only owner for that once acquiring, so he can release. So now this time you can see threads are executing one by one. You will get clear regular output here. Good morning, Sai. Good morning, Sai. 10 times after good morning, Mohan. Good morning, Mohan will be available here. So this is what thread synchronization mechanism by using what technique? Lock technique, we can say that. Thread synchronization by using lock technique. Got my point? Look at here. So after executing one thread, next thread is going to start because first thread release the lock after completion of execution and second thread can acquire the lock again. Second thread can acquire the lock, you can see. Okay. Yes, but this is clear output. Data consistency is available. Execution is very clear, sir. You can see data consistency is available. Execution is also very clear. No problem at all here in this case. Okay. Next, what is the problem? The simple lock. Okay, problem with simple lock technique. There is a problem, sir. Some problem is there in simple lock technique. What problem is available in simple lock technique? We'll look into that. So problem with simple lock. Problem with what actually? Simple lock technique. Simple lock in the sense, first one is first method, simple lock. So the problem is what actually? The standard lock or simple lock object does not care which thread is currently holding that lock. Okay, it is not caring about which thread is currently holding that lock. I can say that the standard lock object does not care which thread is currently holding that lock, which thread is currently holding that lock. If the lock is held, any thread attempts to acquire the lock, then it will be blocked. Okay, thread blockage is there. Suppose your T1 thread is acquiring the lock. In the middle of T1, T2 thread is acquiring the lock. For example, assume that here T1 thread acquire the lock first. Okay, T2 thread again, while executing T1 thread of this code, again T2 thread in the middle, if it is acquiring the lock, attempting to acquiring the lock, then threads will be blocked, I am saying. Why? Because this normal standard lock object don't know which thread is acquiring the lock currently, T1 thread or T2 thread. So how many threads are attempting to acquire the lock, it will allow. So already one thread is acquiring the lock in the middle without releasing that lock. How that T2 thread can acquiring the lock or not? Yes, if it is T2 thread is attempting to acquire the lock, obviously locks threads will be blocked. This is the problem actually. Thread blockage is there. So to avoid this thread blockage system, we can go for which technique, R lock technique we have to use. R lock. R lock stands for re-entrant lock, we can say that. What lock? You can say that re-entrant lock. Re-entrant. What is this R lock? I will tell you. First of all, what is the problem with the simple lock? I will show you an example. Okay. So in which case a thread can acquire the lock again and again, and how threads will be blocked. Okay. In general, in the recursive function means, observe here, in the process of finding factorial of given number. Okay. process of finding factorial of given number. Recursive function is there, no recursive function. Recursive function in the process of finding factorial of given number. A function that calls itself every time, no? Whenever a function that calls itself every time, that means a thread can acquire the lock again and again or no? Yes. In that context, threads will be blocked when we use normal standard lock object. To avoid that, okay, blockage of threads, then we can go for reentrant lock. Reentrant lock in the sense a thread can acquire the lock again and again like that. That is reentrant lock. Let's see the example practical implementation here. So for example, you can see this from threading import star is there. Okay, so df factorial function, I'm taking factorial of n, factorial of n. So here I'm taking lock object here, L equals to lock, normal standard lock object only, L equals to lock. Now you can see L dot acquire, L dot acquire. Now if n equal to 0, that result is what actually factorial of 0 is, result is 1 only. Else block I'm taking, else block, else block. What is that else block? Result equals to n into factorial of n minus 1. Now L dot what actually release method, L dot release method. Return result, I can say that. Return result. Now coming to the def results function I'm taking. Res I'm taking. This is my function name. This function I want to execute through threading only. So I'm printing this. What is this? The factorial of factorial of factorial of n is, factorial of n is, okay, then factorial function I'm taking, factorial function n only. Now coming to this, I want to create threads. T1 equals to thread. Okay. Target equals to what actually? F1 function I'm taking. Sorry, target equals to res function. Res. Args equals to, I'm taking 4. 4 equals to 4 I'm taking. 4 arguments. Okay. Target equals to res. Args equals to 4. T1 thread. Next T2 thread I'm taking. T2 is there here. T2 thread. Res args equals to 5. 5 factorial I'm taking. Now let's start T1 thread. I'm starting. T2 thread I'm going to start. So in this case, threads will be blockage. Yes, there is a chance of thread blockage systems. Why threads will be blocked, sir, in this context here? Why threads will be blocked? Okay, threads will be blocked. Why threads will be blocked? The reason is, you can see this. My function name is res. It's a result function. And I'm calling the target function res by using T1 thread. Whenever T1 thread is acquiring the lock, then T1 thread should release the lock only, no? Yes, compulsory. Now you can see result equals to n into n factorial of n minus 1, L dot release and return release. So T1 thread will call the target function res. Res, we are passing 4 value n, then it will call factorial function, a factorial of 4. It will go to 4 factorial and immediately T1 thread acquiring the lock. 4 equal 0, result equals to 1. But actually 4 equal 0 not correct. It will go to else block. Result equals to 4 into factorial of 4 minus 1. 4 minus 1 is 3 only. Again, for finding factorial of 3 purpose, the function should call back again itself or not? Yes. Whenever the function is calling by itself, again T1 thread only can attempting to acquiring the lock. Again and again it will attempting to acquire the lock. So in this context, threads will be blocked. Now you can see the example, you will not get any outputs, sir, because threads are blocking. So normal standard lock object doesn't know which thread is currently holding that lock, I'm saying. Even T1 thread is holding that lock. But again, T1 thread is attempting to acquire the lock. So this lock object, standard lock object, don't know which thread is currently holding that lock. That is the problem actually. To avoid this problem, if you want to allow same thread acquiring multiple times, acquiring the lock again and again, then we can use what lock technique actually? Reentrant lock, we can say that. R lock concept we have to use. R lock in the sense reentrant lock. Reentrant lock in the sense a thread can attempt acquire the lock again and again any number of times. Yes, first T1 thread is attempting to acquire the lock one time. Again, T1 thread can acquire the same lock again and again, it will allow. So this is what thread reentrant lock through we can achieve this concept, because factorial of finding purpose, every thread can acquire the lock again and again. But then only it will find the factorial of given number. Factorial means recursion. Recursion means a function that calls itself every time. So in this context, there is no output, sir, because of threads blockage here. So let's run this R lock through now. You can see R lock, just R you can add. R lock in the sense reentrant lock. Once I run this, now you can see we are getting output or not. The factorial of 4 is 24. The factorial of 5 is 120. But in this example, R lock technique, what is happening? R lock stands for reentrant lock. So reentrant means a thread can acquire the same lock again and again. If the lock is held by any other threads apart from same thread, then only threads will be blocked. Otherwise, same thread, it is attempting to acquire the lock again and again any number of times. Threads blockage is not available. So this is the problem with lock concept. How to avoid the problem using R lock. I'm using lock concept again. Now T1 thread, whenever T1 thread is starting the target function res, it will call res function by taking n value 4. 4 factorial, it will call function n value 4. Immediately T1 thread will acquire the lock. 4 equal 0 not correct. It will go to here. 4 into factorial of 4 minus 1 factorial of 3. Factorial of 3 purpose. Again T1 thread should attempting to the acquiring the lock. Immediately threads will be blocked, because thread should not be acquired the same lock again and again. You can see threads blocked. So that to avoid this, what we have to use? R lock technique we have to use. R lock in the sense what? Reentrant lock. Reentrant lock in the sense same thread can attempt to acquire the lock again and again any number of times according to their requirement. This is reentrant lock through we are achieving this only. So reentrant lock through we can avoid thread blockage system only. This is the next semaphore, next synchronization technique, R lock. And semaphore concept is there. Semaphore is the third synchronization concept. So difference between lock and R lock is what? Lock object can be acquired by only one thread at a time. Lock object can be acquired by only one thread at a time. Even owner thread also cannot acquire the lock multiple times. R lock object can be acquired by only one thread at a time, but owner thread can acquire the same lock object multiple times. Owner thread means who acquired the lock. That person, that lock can be able to acquire the same lock again and again is possible. And lock technique, it's not suitable to execute recursive functions. And R-lock technique is best suitable to execute recursive function, because in recursive function, one thread should attempt to acquire the lock again and again compulsory. So this is lock technique as well as R-lock technique. And what is the semaphore technique, sir? Semaphore means what? In the case of lock and R-lock, at a time only one thread is allowed to execute, but sometimes our requirement is at a time particular number of threads I want to allow to execute. Particular number of threads means at a time 3 threads I want to allow, 4 threads I want to allow, 5 threads, 6 threads, any number of threads you can execute at a time. To handle this, we can go for semaphore concept only. We cannot go for lock technique or lock technique. So at a time, if you want to execute 4 threads or 3 threads or 5 threads completely, then we can go for what technique? Semaphore technique we can go for. Semaphore can be used to allow to execute at a time multiple threads. Semaphore is the advanced synchronization mechanism. So we can create semaphore object like this simply. S equals to semaphore, semaphore, semaphore. And here we can say counterpart value, counterpart value. And S equals to semaphore semaphore. Counterpart value I'm taking 4. That means 4 threads I want to allow to execute at once. But your counterpart value, if I don't give any counterpart value, by default counterpart value is what? 1. 1 means at a time only one thread is allowed to execute. Counterpart value is at a time only one thread is allowed to execute action. One thread is allowed to execute. If I don't mention any counterpart. So counterpart 2 means 2 threads allowed to execute at a time. Counterpart 3 means 3 threads will allowed to execute like this. For example, counterpart is 4. That means what? 4 threads are allowed to execute. Every time when thread executes acquire method, okay, whenever thread calls acquire method, then counterpart value decremented by 1. Already thread is acquiring means still how many threads should be required? 3 threads required. Again, one more thread is acquiring means still how many threads are required? 2 threads are required. Like this counterpart value decrement by 1 every acquire method calls. And every release method counterpart value increment by 1 again. So 4 threads are there. I'm calling acquire method. One thread is acquiring already. So 3 threads remaining need to be executed. Again, I'm calling acquire method. 3 threads is there. One thread is already acquired. Remaining 2 threads are executing like this. Remaining 2 threads are executing like this. Got my point? So for example, here in this case, so there is no counterpart. By default, counterpart value is what actually? 1 only. So default counterpart value 1. So every release method counterpart value increment by 1. Every acquire method counterpart value decrement by 1. This is semaphore concept. So semaphore will allow multiple threads at a time it will execute for your program. Let's see this semaphore concept, how does it will work. So in this example only, I'm taking semaphore concept. Look at here, in previous example I'm going. So here instead of what we can say, lock object, I'm creating semaphore object. Semaphore is counterpart is I want to execute 3 threads at a time. So 3 threads I want to execute at a time. S dot acquire method and S dot release method. S dot release method. And now you can see 3 threads means I want to create multiple number of threads here. Total 6 threads I want to create, and 6 threads I want to start also here. Let's look into 6 threads I want to start. T1, T2, T3, T4, T4, and T5, T6. These are the thread 6s. And the values I'm taking like this. I'm taking Durga and Raj and Mani and just Kiran. I'm taking Kiran. These are the values. And T1 dot start, T2 dot start, T3 dot start, T4 dot start, T5 dot start. Okay, T6 dot start like this. So now you can see semaphore object will allow how many number of threads at a time? 3 threads are allowing to execute at a time. At a time, 3 threads are running because 3 counterpart I'm giving. No, 3 will run. Every attempt, 3 threads are going to execute. Every single attempt, 3 threads are going to execute. 3 threads, 3 threads, 3 threads like this. So 3 attempt is there available. So if I don't mention here any counterpart like 0 I mentioned, that means counterpart value by default what actually? 1 only. Let's stop debugging and rerun this. Now you can see counterpart value will be 1 by default. One thread at a time it will allow to execute. So as per your requirement, you can decide how many number of threads if you want to allow to execute 2 threads or 3 threads or 4 threads, then we can go for semaphore concept here. Okay, so let me stop debugging, it's not required. Next, what I'm trying to do here, okay, so next what I'm trying to do, bounded semaphore concept is there, not simple semaphore. Bounded semaphore, simple semaphore difference is what I will tell you. In the semaphore concept, okay, in the semaphore concept, number of acquires methods can exceed the release methods also. Number of acquires method can exceed the release method. Suppose from threading import star is there. Okay, S equals to semaphore I'm taking, semaphore. So 2 is the counterpart. So that means S dot acquire, S dot acquire. 2 times I'm going to acquiring the lock. 2 times I'm acquiring the lock. How many times should release the lock generally? 2 times only. But here in normal semaphore, number of releases also acquired. 2 times I acquired the thread, but 3 times I released the thread. So here no problem at all. Okay, end of the program I'm taking, no problem at all in this case. Why no problem? You can see this thread 10.py. There is no problem at all in this case. So in normal semaphore, number of acquires methods need not to be matched with number of release method. Here 2 times I call acquire method, but 3 times I release method. This is okay, no problem. It is valid because in normal semaphore concept, we can call release method any number of times irrespective of how many number of times you are acquiring that. But in bounded semaphore, exactly same as semaphore only, but bounded semaphore will not allow you to release too many times. So how many number of times you are acquiring, that many number of times only we have to release the lock. That is the problem actually. That is the clearly example. This mechanism is best suitable in real time because if you do any mistakes, programmatic mistake, so if you call 2 times acquire method, but you are not matching release method 2 times, 3 times is there, it will give error clearly so that you can understand somewhere I released many times. So semaphore released too many times is there here. This is not good idea. So to avoid programmatic mistakes, okay, so to avoid programmatic mistake, to prevent programmatic mistake, bounded semaphore is recommended compared to normal semaphore, because normal semaphore what will happen, how many number of acquire methods are there? 2, but release methods how many are there? It is exceeding acquire method, three release are there, but still it will work. But that is not good practice in reality time, so we can avoid that programmatic mistake. So then go for bounded semaphore, it will be clarity because it will allow only how many number of times you are acquiring the method, number of times release the method only allow. Otherwise, if you exceed the release method, it will give error. Again, you have to set this. So it will happily execute now. 2 times acquiring, 2 times releasing. So this is about multi-threading concept in this session. Hello. So my battery is completely low, sir. Try to understand there was a power issue from last night onwards. So unfortunately, this was completely shut down my system all of a sudden. So we'll continue in tomorrow's session. Okay. Tomorrow we'll go for next concept, that is decorator or generator concept we'll discuss.